Hello, we are going to look at this nice little sequence problem here, and we are asked, is it convergent or divergent? Does it have monotonic character to it? And is it bounded? So let's go through that now. It is n times -1 n plus 2. Whenever you see this nice little thing of -1 to the n power, you know that this is an operator that's telling the function. It's telling the function, for every value successively, go positive, then go negative, then go positive, then go negative, then go positive, then go negative, until you run out of n values. Or if you go to infinity, well, you're indeterminate. Well, you know, what can you do? But anyways, given that we have this operator, we can deduce one thing about the monoticity of this function. We will not even ask if it's convergent or divergent yet. We're just going to ask, is it monotonic? So monotonic. Let's plug in 1. Let's see what we get in our sequence. So a sub 1, what is that equal to? Well, 1 times -1 to the third, that's going to be -1. Let's plug in 2. 2 times -1 to the fourth, that is going to be 2. A sub 2. For a sub 3, our third value in our sequence, we're going to do 3 times -1. So this is -3. So notice we're increasing by 1 every time, but we're also flipping our sign back and forth and back and forth. What does this tell you about the monoticity? Is it always increasing or is it always decreasing? Well, you say it's going back and forth. From a sub 1 to a sub 2, if I plugged in 0.5, well, it's going to be increasing. And then from a sub 2 to a sub 3, it's decreasing. And this pattern will continue forever and ever and ever and ever. So this sequence is not, it's not going to have bounds to it, and it's also going to not be monotonic. So this is not monotonic. So we deduce that. I want to make this a point. But the bounds I said also do not exist. Also do not exist. The bounds do not exist, and the reason for this is, notice for every term that we plug in, this number grows. We can't plug in 5 million and get a lower number than our previous terms, okay? It's always growing. And because of that, there is no upper bound. So there's no upper bound. Or we are not bounded above. There's no ceiling to this function. Okay, is there a lower bound? Well, we can plug in 0, and we're going to find that our lower bound is in fact 0. So yes, we have a lower bound. Of 0. Because we're starting at 0, that has to be our lower bound. Alrighty, and that would be 0 for the lower bound. Okay, now we're going to ask, is this sequence, is it converging to one number or is it diverging? Okay, well, you should immediately look at that and say to yourself, that is divergent because of our rationale here. Can we show that with calculus? Yes, we can. We're just going to plug in infinity here. We're going to take a limit as n approaches infinity for n minus -1, n plus 2. This will just be 1, some factor of 1, and then n will be infinity. So if the limit is evaluated, because if we plug in infinity where n is, it's just infinity times a constant, that's going to be infinity. So this limit is approaching infinity, and therefore, because of that reason, this is a divergent function. Or not a divergent sequence. So, to summarize, this is not monotonic because it's flipping back and forth signs. It's decreasing, increasing, decreasing, increasing, decreasing, increasing. Our bounds, we have no upper bound, but we do have a lower bound of 0. And it's divergent because when we approach infinity, the function's always growing, right? You can think about it. Think about like integrals, right? When you take the integral of some function from infinity to 1 or something, and the function's always increasing. Well, the area under that curve is infinite. You can't express it. Same kind of thing here. It's divergent. The sequence is divergent because our sequence is approaching infinity. Hope you guys enjoyed this episode. If you did, please drop a like, comment, and subscribe. I hope that you have a wonderful day.